appreciate you so very much.
Good. Do you guys happen to have like a clicker thing or something else? I guess it's something else.
Yeah, it's like clicker's being used. But I can pull this closer to you.
Oh, yeah, that's great.
That way.
That's great.
Okay, cool. Looks like everything's good to go. Let me know if you guys need anything else. You got the parking validations, right?
Yeah, I have.
Okay.
Pretty much. And yeah, and should be probably pretty soon sailing, but I'll find you.
Yeah.
Good. And I'll make sure they put the chairs back.
Yes, please.
Alright, let me know when you're ready to go, and I guess I can go ahead and get us started whenever you're ready.
Yeah, it'll just be a minute.
Yeah, there's no rush. It's a small crowd this time, and we'll just be slow and cozy about it.
Cool.
Also, I'll just reiterate, really appreciated you talking to the kid. I thought you gave him a lot of good advice.
Oh yeah, so how's he doing?
I mean, you know, he's going to Savannah College Art and Design, you know, so he's doing all right. You know, he's well, I keep looking at his projects and just, I mean, since even when you talk to him, he's gotten more impressive with his projects. I continue to be astounded at the rate of how quickly he's improving.
Is there, what should I use to log into here for the network?
Probably guessed.
Chemical Factory?
Yeah, Chemical Factory. Let me ask what they're wanting speakers to use for it right now. 1 second.
There's a lot. Yeah. There's a lot there. Cool. Well, thanks for coming out, the people that came out. It's good to see a couple people. Are you guys programmers? Do you guys know how to program? No programming?
I know HTML, CSS, and I'm learning Python. Just started.
That's actually perfect.
I'm a programmer. I'm basically an analyst, basically. But
that's great. I'm gonna say, you know, like a little bit of programming? Yeah, that's perfect. Because the stuff I'm teaching helps a little bit if you know just kind of the basics of programming. But you definitely don't need to know advanced programming.
And actually, let me see what I can actually, because he's not around right now. Let me see what my network is on right now. 1 second.
Okay. I have
yeah, try members, although I might have to.
Members.
Yeah, though I might, that one may require a username and password, which then means I have to do what
Here,
is.
JavaScript haikus, yeah. Well, that's kind of one of the names of this talk. Is the whole idea is writing super tiny programs. So the idea is like putting a program into a tweet, something the size of a tweet. So 140 characters, yeah. So it's a really small space. And that's kind of how we got started, mostly what I'll be talking about. And kind of like, I feel like it's got a lot of parallels with haikus and like poetry. Because when you think about like programming, a lot of people usually think about writing like pretty big programs. Definitely bigger than these programs. So haiku is kind of like an exercise, like breaking everything down, compressing into a small space to nudge down.
There you go, you should be on.
It seems to be working okay here.
Yeah, and whenever you're ready, I'll give my one a little pre-talk spiel and then we'll get going.
Yeah, go for it.
Cool. Alrighty. Welcome everyone to the latest installment of the EFF Austin Monthly Meetup. Weather was not great this month, so it is a small but dedicated crowd. We appreciate the few of you who made the trek out, and anyone watching online. Apologies getting the live stream up on time. It just seems to be one of those months. But anyway, soldier on we shall. So, yeah, I think you all know who I am, at least in attendance, but if anybody new is watching online, my name is Kevin Welch. I'm the current president of the board at EFF Austin. You may be wondering, what is EFF Austin? Well, we are an Austin-based digital civil liberties organization. We work closely with electronic Electronic Frontier Foundation out of San Francisco. They're the nation's oldest and largest digital civil liberties advocacy organization. You kind of think of them as the ACLU of the internet. They work to protect your rights in emerging technological spaces, especially your First Amendment right to free speech and your implicit Fourth Amendment right to privacy. They've been involved in many of the digital civil liberties battles over the last 30 years, advocating for net neutrality, end-to-end encryption, protecting Section 230 of the CDA, which lets people speak freely online, and just all sorts of cool stuff. They're pretty awesome people. I suggest you go to their websites and resources to learn more. They also sponsor something that is called the EFF, or the Electronic Frontier Alliance, which is sort of a kind of network of peer-to-peer activist orgs all around America. There's about 100 of them. EFF Austin is actually the oldest member of the EFA. We're almost as old as the EFF, going back to the early 90s. I think EF Georgia from 96 is the second oldest. They're out of Atlanta. And for a long time, EFF Austin was actually not only the only member of the EFA in Austin, we were the only one in Texas, despite there being 100 groups all over the country. Though we're happy to report that there's another group here in town, in Austin, who are also now members of the EFA. They're really cool people. We suggest you get involved with them as well, especially if you're interested in civic activism and coding for public sector good. Yeah, but basically that's a little bit about the history of us in EFF. We, primarily an educational organization, EFF Austin that is, mostly in the form of meetups here at Capitol Factory the second Tuesday of every month at 7 p.m. currently. We will not be having our normal meetup in March due to South by Southwest. Whether or not we will have any kind of informal meetup or party at this point kind of remains to be seen. The board has not had a lot of bandwidth to plan something, and Lord knows doing anything around South by is a nightmare these days. So we hope to have at least something casual for community members together, but it may not be anything fancy, but stay tuned. If you would like to see fancier things, well, it really depends on if you know any eccentric tech millionaires who want to fund cyberpunk parties, throw them my way. That's usually how we've done these things in the past. So if you want to see more elaborate things, that's usually what it takes. We also, like our national namesake organization, we do get involved in certain political efforts, both at the local and state level. We were involved in the fight around automated license plate readers here in Austin. We weren't able to stop them from coming back, which would have been our preference, but we did get much stronger data retention rules in place around that, which we were very proud of. We've also been consulting with the city and state levels on things related to AI regulation. In fact, this may not be entirely public yet, but there's some new stuff at the city level coming down on AI regulation. A lot of the initial stuff addressed just kind of internal city HR stuff, and I think there's some stuff coming down that may start addressing some of the more external things that I think citizens were concerned the tech might be put to use of. So we're going to be involved in those conversations. There's also a number of bills in our wheelhouse at the Texas Ledge right now. Probably the biggest one everybody has their eyes on is the bill purporting to attempt to outlaw algorithmic discrimination, which we feel is a well-intentioned bill, albeit it has a number of major flaws in its current form, which we hope to be able to advocate with Rep. Leone to introduce it to try to get some improvements there. There's a few other bills in our wheelhouse. There's a weird one related to fusion centers and Department of Public Safety, surveillance stuff that we think might damage oversight. There's also a bill to weaken Texas' otherwise pretty good law protecting against SLAPP lawsuits. We hope that one doesn't go much anywhere. Yeah, and I think there's a few others floating around. But we encourage you to get involved. Sometimes you can just walk straight into a legislator's office, believe it or not, and meet with their staff and tell them your concerns. Don't necessarily have to make an appointment, but depending on the day and legislator, you may get sent away and may need to basically take a card from their staff and try to plan a more formal appointment. But do not be deterred. You do not need to be anybody important to talk to your lawmakers. You literally can walk into their office and talk to their staff. So if you're more interested in getting involved in trying to advocate at the Ledge, I encourage you to talk to me or email us at info@effaustin.org if you're watching remotely. Oh, and I guess I would be remiss if I did not mention, just because, I'm about to introduce our speaker here, which I will say that compared to some of our heavier political meetups or talks, this one I think is going to be a kind of nice breath of fresh air, given everything going on in the world right now, which, you know, depending on your political persuasions, it may be more depressing than other things, but a space where it is very relevant to the things we watch, and I may not have all the details right because this actually literally just came out today, but if you, like myself, regardless of your politics, have been watching what has been going on with Doge being allowed to access highly sensitive personal information of Americans in a way highly violating of security and privacy, I'm actually happy to announce that EFF and a coalition of privacy groups have actually literally today sued Doge and the Office of Personnel Management for violating the 1974 Privacy Act. This act was created in the wake of Watergate as well as the COINTELPRO scandals. It basically says Americans' personal data held by the government is of absolute sensitiveness, and unless an American gives their explicit written consent, no one may access that data. So it's pretty cut and dry, the law is being broken here. We're happy to see EFF is suing, and we stand ready to do whatever we can in our little, much smaller capacity to assist in the fight. Okay, I think that gets the boring but very necessary activism portion of the show out of the way, so I will go ahead and introduce our speaker for something that will hopefully be much lighter. I always like to feature things like digital arts, digital culture when I can, just showing that, you know, the reason we fight for the electronic frontier is because we actually think a lot of really cool stuff happens there when people are allowed to flourish and express themselves through technology. So we think it's pretty cool. So yeah, let me pull up my bio here. I always like to introduce my speakers properly. So get this up here, and then I will turn it away to the actual interesting meat. Okay, so yes, our speaker this month is Frank Force. I asked Frank to speak after I saw him give a variant of this talk at Nerd Night. I was very impressed with his work. Thought it'd make for a fun, cool little talk here as well. So Frank's a renowned game developer and generative artist based in Austin, Texas, with over 20 years of experience in the gaming industry. He's worked with many well-known companies, including Rooster Teeth, Affinity, Volition, and Midway Games. He's also famous for creating over 1,000 tiny JavaScript programs and releasing many games, art, and tools. He's the creator of the open source LittleJS game engine and ZzFX mini sound system, and also won Optical Illusion of the Year 2019 with a JavaScript program. His other interests include cooking, gaming, gardening, Buddhist studies, and learning Italian. Sounds like a well-rounded guy to me. He currently resides in his Austin, Texas home with his wife and cat. So anyway, yes, Frank is an expert at a sort of coding tradition known as code golfing, which, you know, much like golf, you're trying to get below par. Code golfing is about how can you accomplish the most impressive things with code with as few characters and lines of code as possible. How can you make code do things you literally didn't think it could do? And while I don't know, but Frank's an expert on it, so without further ado, let's have Frank take it away.
Hi everybody. Thank you so much for coming out. Thanks to EFF Austin, Capital Factory, and it's just great to be here. I've done this talk a couple times. Usually I'm like rushed through it, and since there's less people and and I don't have to rush, if you have any questions, if anyone has questions while I'm talking, just feel free to just raise your hand and I can just, you know, because we can mix it up a little bit.
I'll keep that in mind. I might actually ask you, how's the code actually doing that?
Yeah, we're going to actually get into that. I want to do some live coding afterwards. Yeah, as Kevin said, I've been working in the video game industry most of my life. I've worked on a lot of pretty cool games. Worked in a couple of studios in Austin, certain Affinity, and Lightbox, and Rooster Teeth. And I also do indie dev stuff too. I make a lot of indie games through some of them that I made. And I also do generative art. I brought a couple of my generative artworks. So these artworks also use JavaScript. They don't use any type of AI or anything like that. They're completely code-driven, completely code from scratch too. So they have like, for example, they have like a Floyd Steinberg type dithering effect. That's all code from scratch. Everything's code from scratch, and all these projects, like a comic book type space comic book generator, and trees, lots of trees. But my favorite thing to do is to make tiny programs. So I've made over 1,000 of these tiny programs. Some of them are more animated, Some are more just like a single image, but they're crazy fun. Nearly every single image, almost every single image you'll see in this entire presentation will be one of these tiny tweets, which are 140 character programs. So let's talk about tiny code. So what is tiny code? Well, Kevin said it's like code golf, or size coding is another way of calling it. I kind of think that code golf is slightly different from what I do, because for example, there's a website, code golfing website that's really popular. And the thing about code golf that's kind of different, I feel, is like, with code golf, you have a goal. It might be like print out all the prime numbers, or something like that. It might be like, show the Fibonacci sequence. That's the goal. And you have to do them as few as characters as possible. Whereas size coding is almost like the opposite of that. You have a fixed amount of size, 140 characters. And what you're trying to do is actually fill up that entire space. And occasionally, sometimes I might just try to make something like really tiny, like half that size or whatever. But generally speaking, with size coding, when you're given a particular space, these ones are 140 characters, but there are a lot of competitions that are usually in multiples of 256 characters. So you get 256, 512, 1K, and then also going down to 128 and 64. And those actually go by bytes usually. We're going to go by characters today, and I'll show you some cool stuff we can do because of that. And there's all kinds of stuff you can do with tiny code. It's not just visual stuff. You can do music. You can do like animated things. You can make games. You can use these pieces as smaller pieces in larger projects too, which is, I think, one of the greatest uses of it. So have you guys heard of the demo scene? Has anyone heard about the demo scene before? No? It's actually way bigger in Europe. It just never really caught up quite as much in the United States. But it's really huge there. You probably heard of LAN parties, I think. At least. This would be like a LAN party here, which is a demo scene is kind of like a LAN party, but they're also create these super small programs that they show, which have music. They're usually music synchronized to visuals, and like that one at the top right is an example of the 256 byte one for MS-DOS, which is a popular MS-DOS. 20, 30 years ago, it's still actually one of the main platforms for the demo scene. And so it's really interesting because like the demo scene, these programs, like a MS-DOS program, and most of these programs are binary programs, which if you know anything about programming, you're compiling that and it's going to be running byte code, computer code, right? But with JavaScript, one of the kind of cool things is it's not binary. You're literally looking at the source code. There's no way to compile a JavaScript program. You can only have the actual code. So I think that's kind of cool, because when you see, at least for me, when I see some of these demos, like you have to know a lot about the hardware and stuff in order to understand how it works. And the JavaScript, I think, takes a lot out of it. It simplifies it a lot. So let's talk a little about these code golf basics. Just like how do you like make something smaller? Normally when you're programming, it's probably not your main goal to make code smaller, though it is an important goal for really all types of software engineering, because there's a lot of code bloat that can happen, and when you start copying and pasting, you start just like not refactoring when it needs to. I think we all know things can get really out of hand and just make code very difficult to deal with. But with size coding, we're going to take it kind of to the extreme, where we're going to remove everything that's not necessary, including comments, white space, and like variables will just be single letters, everything like that. We're going to do everything we could possibly do, and I'll show you what that means in just a second. Another really, really cool thing about JavaScript live coding that is really separates it and it completely changes the game, in my opinion, is a live editor. So usually with coding, you compile your program, and then it runs, and you see it, and then you change some stuff, and then you compile it, and then see it. But with a live editor, every time you type into the live editor, it automatically rebuilds and changes it instantaneously. So when you type in a number, you'll see your effect happen right away in real time. And it makes the act and the joy of ZzFX experience so much more fun because it's so much more tactile when you're able to just like see that feedback right away. And I'll be showing you guys a live editor in a little bit how that works. So with this tiny code, I talked about the demo scene a little bit. That's kind of the main way people like share and kind of consume this tiny code. But there are also other websites on the internet where you can post these things anytime you want. Twitter is my favorite one, and that's what I'm talking about today. But there's also a shader toy, which is specifically just for WebGL shaders. And there are competitions like JS1K, where you the goal is a 1 kilobyte JavaScript file. So you can do quite a bit more than you could in 140 characters, but still extremely limited and just a really fun exercise. So Twitter is my favorite thing, and I'm going to tell you guys about that today. So it's a website called Twitter.net. And it originally, so the idea of Twitter, this is from like almost 10 years ago, I think. It's from demo plus Twitter equals Twitter. So demo is, not when you think of like a demo as like a game demo, or like, it's more like the demo scene. A demo is like this visual art code thing. That's what a demo is. And Twitter, because they chose 140 characters to kind of match it to Twitter to see what people could do in 140 characters. And it works kind of the same way. You can create a username, you can post these tweets, and you can remix tweets, and you can comment on tweets, and you can like them and stuff like that. So it's kind of this, it's a very small community, but it's a really fun place to like post and iterate and remix other people's work, see what other people have done. It's a lot of fun. And like I said, pretty much everything I'm going to be showing you in this talk is going to be tweet. 140. Here's just an example of what kind of size we're talking about here. So one of the fun things about Twitter is whenever you create a new tweet, you automatically presented with this these 9 bars moving left and right. That's called the Twitter default program. And it gives you this code by default to clear the canvas. So the canvas is a 1080p canvas, so it's 1920 by 1080. And it just does a for loop. Everything here is going to be pretty simple programming. So it's not going to get much more complicated than a for loop and addition, multiplication, and a few trig functions. In this case, there's a few shortcut functions provided. So you get a couple trig functions, like that st is a sign of t, and t is time, because that's passed automatically. It kind of creates automatic loop for you, so it's automatically getting the update, calling that code 60 frames per second, creates a canvas for you. And so there's a little bit of a boilerplate code, HTML, that it kind of puts it in. And but it's a really simple boilerplate, which is what I like, because it's very close to vanilla JavaScript. So for example, that program, on the left is what we start with. If we want to minify it, we will first remove the comments. We don't want any comments, because that's just wasted space. The c.width is the width of the canvas. And it's a little bit shorter to clear the canvas by doing a for equals 0, kind of a trick that you just kind of learn, you do these things. Iterating down rather than up actually saves a little bit of space. You can see how it says for I equals 9 instead of that larger for loop stuff at the top. It's kind of just like an interesting way of kind of, like all these little things add up. So we do that, and then yeah, that's all we're going to do on that one. Then on this one, we're going to push it a little bit further. You know, we're going to do c with for equals I equals 9. Kind of smush all that stuff together. And changing the 100 to 99. So kind of just fiddling with numbers. If you have a number that's like 100, obviously 99 is going to give you basically the same thing. You know, one byte smaller. So
Any and all tactics are fair game.
Anything you can do. Yes, exactly. All is fair. So, like I said, there's a bit of a template that happens automatically. So you don't write any of this code. The only code you write is where it says delete code goes in here. It automatically kind of creates that for you, and you don't ever see any of that stuff. But just to show you what an HTML file would look like that runs one of these tweets, any of the tweets you see in this presentation, just paste the code right where the tweet goes there, and it will be able to run it. And then just a couple constants for sine, cosine, tangent. You get a color. R is giving you an RGBA color. I use that quite a bit. And you get the context for your 2D canvas, and I'll tell you a little bit of that too. But first, let's talk about the default tweet remix. So this is one of our favorite things to do on Twitter, is to take the silly concept of 9 bars and kind of just like see what we can do, what kind of creative things people can do in that same space as well. And here's some of my favorite community ones. And so I've tackled that too. I've done a lot of different ones. It's just one of the things that you're going to want to do when you get on there. A lot of fun to come up with new ideas. So, so I had mentioned there's a little bit of a difference between characters and bytes. And this is, it's of high contention at this point, but the fact of the matter is, when they created this website and the way Twitter also works, is it counts characters, which some of you might know, a character, a Unicode character, can be more than 1 byte. An ASCII character, the core ASCII set is just 1 byte. But once you go up to Unicode characters, emojis, all that kind of stuff, they can be quite a few bytes. So you might see some tweets that look essentially like this, which is, it looks almost like nothing. Just a bunch of Unicode characters which are not being drawn. They're actually different. You can't see that, but there's data contained within those Unicode characters. Because we discovered a way to kind of pack in more data than should really be allowed in the 140 characters. And we can pack up to 194 bytes when we only have 140 characters. Because we're going to need the unpacker, which is that eval and escape, basically everything that's not in that string there. And it's kind of tricky, but I mean, I don't want to get into too much. I did not understand how this stuff worked at all when I first got into it. But you don't even really need to know, because it can compress and uncompress tweets automatically now. Like, we made it do that because it just became something a lot of people wanted to do. So basically what happens is you call escape, it converts that junk into this kind of thing, escape characters. Then you kind of pull out those red characters. Then what you're left with is the stuff you want to keep. That stuff gets unescaped, gets converted back to regular ASCII, and then you have, so here's what the result is, JS, which is stored in this character. Just something to be aware of. But another really cool thing, question?
Sorry, just for context.
Yeah.
How much did you say the size was, the maximum size was before doing that trick?
The maximum size is 140 characters, but that gets
Put it in bytes, because you said you could put more data using the Unicode, or did I
yeah,
miss
well, yeah, that's true. Well, actually, that's kind of what this slide is about.
Oh,
so
okay,
140
sorry.
characters. So the default size is 140 characters, and that usually your programming is ASCII, but a lot of times with these tweets you want to use emojis and stuff like that, and emojis can take up more than, like I said, more than 1 byte. So, but if you're just using ASCII, you are limited to 140 bytes. Really, unless you do other kinds of tricky stuff like what we're doing here. So I just showed you how we could pack in code into that space, but we can also pack image into that space too. So into that same kind of concept of packing it into Unicode characters, I've been able to pack a link from Link to the Past and the Mona Lisa, which I call the Mona Duitza, and I did a couple self-portraits in there.
So you're basically taking a font and you're basically compressing non-font data into a Unicode code point.
Well, it's not a font. It's not a font.
Or a typeset, I guess I should say.
It's not, well, it really is, well, it doesn't really matter what ultimately the characters look like. The characters, I mean, in this case, well, there's one bicycle rider there. Because sometimes, occasionally, some of the characters are representable. It's just completely almost random. Because we are kind of just using those code points, whatever they happen to be, and we don't really care about the second half, or we don't care about the first half. The second half is where we kind of sneak our data in. But yeah, I mean, more or less we're packing in whatever data we want, line data, into Unicode. And it's kind of a cool trick, and we've been experimenting with it more and more, and just what other ways can we use it, you know? So anyway, but that's kind of one of the minor things. That's one of the more curiosities, I would call Twitter. It's not something that we're really going to worry about so much. Though, just be aware, a lot of these programs are technically 194 bytes, not 140 because they're compressed. But anyway, so the JavaScript 2D canvas. If you ever use JavaScript to do any kind of graphic stuff, you might be familiar with the 2D canvas. It's just a really simple API that lets you do basic shapes like circles, squares, text, and control over color, shadow, outline, things like that. These are a very small API. There might be 20 or so functions in it. So it's really kind of fun to dig in there, and it's because it's like so simple. There's really not that much to learn. Like if you know how to draw squares and circles, then you pretty much know how to use it. So for example, to draw a rect, it's a fill rect function. You just pass in the x and the y coordinate, the width and the height, draws a rect. You want to clear a rect, same thing. X and y, width and height. Circle is a little bit trickier because you eventually have to call a fill after you call arc, but it's just something you'll learn. Then you've got a fill style to change color, and you have some line functions to do line type stuff, or lines and then fill in the lines. To give you just a quick example of some things you can do with these very, very simple primitives. So you're seeing like I'm making a brick wall there, for example. That uses only recs, and all those recs are the same size. So you might see just using recs, coloring them from black to red, and just leaving one of them out just to give it a little more artistic view. Same thing with these books, just recs. This, just circles. There's a little bit of an algorithm here to pack the circles into the space, and that's kind of what makes it special, but the actual drawing part is just circles. So you can do, you don't have to use the canvas though, like you can use whatever you want. You could even use CSS. You can use HTML. I've messed with tables a little bit, if you guys have ever used an HTML table. And you can even use SVGs. And I have a plotting machine where you can put in a pen, and I've been able to plot out one of my tweets, which I thought was pretty cool. So one of the first things you probably want to get into with Twitter is random number generation. And it sounds like a super mathy thing, I guess, but it's just really important and necessary for art, for generative art, it turns out, to be able to get a randomness, create randomness, and like how do you get it, you know? Well, you get, some people, if you've ever used JavaScript, you probably know about math random, which just returns a number between random 0 and 1. Pretty much every programming language is going to have something like math random to get just a random number. There's also date.now, which is a little bit smaller, and you're going to get a random, like, not random, I mean, it's a date, it's a number, it's a long number, the amount of like milliseconds, I guess, from like the 1970s or something. So it's going to be essentially a random number if you kind of mod it by something and break it down. But the thing about those that make them not so useful is like, you want like a reproducible random a lot of the time. You want a random that you can control and you like know what the output is going to be. So that's why we use these kind of pseudo random number generators that I found to be very interesting. So for example, one way to create a random number is to take sine of that number squared. So if you have an integer, for example, integer is going up to 1,000, you take sine of that number squared, you're going to get a whole bunch of values between -1 and 1, and they're going to be all over the place, you know, and that's one of the smallest ways you can get a random number. Another way is to like take a number to a power and then mod it by a non-integer, we'll say. So when you take an integer to a power and then mod it by a non-integer, it puts it in a really weird place where it's coming out to essentially random noise. I have a bit of a picture here where you might see the randomness, how it looks different. Like it has almost a texture to it when you use these different ways of getting random noise. And you can even do things like, say, sine of x or y, or x and y, or something to get like interesting patterns. And I use that a lot too. So within this space, there's like a whole lot of algorithms that we've been exploring. You can do, like most of it is built on top of loops. But within that, you can also do trees, you can do fractals, you can do similar automata, strange attractors, and simulations with physics. We're getting into doing raycasting stuff now in that same space. And just like, we're still discovering what's possible, I think, because we're still like impressing each other. Like even just like this last year, since I last did this presentation, I've seen more stuff that blows me away. So, for example, some of the games that I've made. Question?
Yeah, I just had a question on that JavaScript 2D library. I actually use ZzFX. I don't know if you're familiar with it, but it's an Airbnb library for data plots. Like, have you found it easy enough to do it just within like simple plots within the 2D canvas library?
Yeah, yes, I do use that sometimes. I do use the canvas library for stuff like that, actually, when I want to like have a whole lot of control over kind of data like that, and I want to do it code-driven, so that I have saved the code, and I might use it for other stuff later, and I want to tweak it in different ways, and maybe I'm sure there's a tool I could probably use, but I don't learn how to use it. So I just use, I use it for all kinds of stuff.
Okay, nice.
Yeah, I even have some graphs on Twitter. I have like a graph of like how many tweets there were each quarter, and it's like just to kind of show the progress of like how that's the interest of Twitter. Like, it's for all types of
what's a good is there some source code that I can look at that online? Do you think there's just like a GitHub one? Maybe I'll do some research. I never researched that far for it, but because I know like whenever you do rectangles and stuff, like it can. Well, I'm not sure how to plug in the plot to make it so simple from a CSV. Like physics makes it really easy, but like I've never. Yeah.
Well, for CSV,
well, so typically the way I do it is like I'll import data from the CSV file, and then I'll with like a time on the X, and then basically values on the Y.
A time series CSV.
A time series CSV. Basically.
Yeah, I mean, I'm sure what I would probably do is just focus on getting that working, which shouldn't be that hard. AI could probably just bang that out for you. It should be like, give me simple JavaScript code that converts CSV to a couple lists, and then
I can barely write simple SQL scripts anymore. That's what AI is great for.
Yeah, it's great. AI is not very good for understanding how these programs work, unfortunately.
No, but it doesn't have a lot of training data.
It doesn't have, well, I don't know. I have the entire database is completely open.
Yes, it's been hoovered up because it's on the open web. And
It is, yeah. I don't know if they have, but they should.
They should have.
Anyway, so I've experimented a little bit with games on Twitter, though it can be tricky because the input takes up quite a bit of space. Most of the tweets are not interactive because you can fit more. But we've done everything from a Wolfenstein, kind of mini Wolfenstein thing, to more like a Flappy Birthday, Pong, baseball, little platformer type games.
Would I be correct that the interactive ones usually have a single mode of interaction, i.e. they're done through a single event listener, just because it's going to be hard this level to get more than one in there?
Absolutely, yeah. So it's tough.
It's like mouse or keyboard. It's not going to be both,
I mean, it's not, when you look at them like that, it doesn't seem like a lot of space, but when you're actually trying to make it fit in your program, it's really tough. OnClick is going to be the smallest one you can get any input from. So some will use OnClick, But you can also, some will use a mouse move, like I made a little pottery thing using mouse move where you can shape pottery. I made a little bit of a interactive water simulation where I used the mouse. So, part of it is, some of it is like when it's on key down, sometimes we try to like figure out better ways to convert the input from the keyboard to how you might move the
Would it be seen as cheating if you added some kind of alias to the Twitter wrapper to make something like on key down more manageable?
Yeah, so I mean, one of the things we're talking about with Twitter is where to go with it in the future. If we do want to make any change to it and what that would be. So, but some people want less, some people are like, I don't want any functions. I don't want sign, I don't want tangent. I don't
Some
want
people
anything.
even think that's cheating.
Some people
What
think that's
can I
cheating.
do with
Yeah.
the defaults? No.
Exactly, yeah.
numbers.
Whereas other people are like, I want to cover more things. Like it might be nice to have a way to get input, like whatever. So right now we're kind of figuring out where to do. But I do like how it is so simple, and there is very little overhead as far as the shim or wrap or whatever you might call it.
And most of it really is just done with legal tricks built into JavaScript.
Yeah, well, there is no way to change the shim. That's already built in. So you just have what is in that space. And people have tried to work around some stuff, but sometimes they've had to patch some things out.
Does anybody ever try to essentially code around the Twitter sandbox and do weird stuff that way? Like
Yeah.
jailbreak the container essentially?
Yeah, we had some troublemakers. It's pretty locked down at this point because the way it works is like when you have an iframe, you can sandbox it, and you pretty much have full control. Like you can't really break out of the sandbox. once
Right,
you're
it's
in
an
there.
iframe with a full shadow DOM. None of those objects even know they're in another
Yes.
context essentially.
Exactly, but there is some things you can do that we have done. And for example, one of the things that's kind of fun is there's like a frame rate timer in the corner of the tweet that shows you like, what is it, 60 frames per second, like what's the frame rate? And we play with that, like we got control of that and we make that into tweets. So yeah, we will do anything we can do to break this thing. Here's one that I did in actual HTML file. This is not a tweet, but just a full entire HTML file that you can load in any browser and interact with to play a Flappy Bird style game. So here's the code, just a little bit laid out, a little bit easier to see. There's not very much HTML, it's just a canvas. And then there's this block of code. It's kind of similar in some ways to how Twitter works, because you need to get the context, you need to set interval, and then there's some gobbledygook in here to do the actual game logic to determine like, where's the wall position and things like that. And the on-click event, you could probably see in the middle is where the input is taken.
This might be very nitpicky, but your comment says 60 FPS, but it looks like your set interval is 16. Am I misreading?
Yeah. So 16 is 16 milliseconds.
Oh,
So it'd be-
milliseconds.
yeah. So that would be 16. It's actually not exactly 60 FPS, but it's close enough. But you can also do 9 milliseconds if you need the same flight.
Yeah.
But I just did 16 because 60 FPS is pretty standard. And Chrome, I think a lot of web browsers kind of recognize that 16 and automatically
They kind of match 60
match up to,
milliseconds to 60
they know
frames
it's,
a
they
second.
know you want it to be 60 FPS, exactly.
Because multiply that number by 16, you get 1,000, right?
Mm-hmm.
Yeah, okay.
Close enough to it.
Yep, got it.
So we've also done audio. It's one of the trickiest things to fit, really. It takes up almost all the space because you need to create audio context, do some boilerplate code of like connecting the buffer, connecting things, and do that kind of stuff. It takes up a lot of space. But ultimately, what you're doing is you're packing a buffer full of samples, audio samples that you're generating yourself with this code, and then playing those audio samples. So in this case, the this function T bit shift 8 NT, that is the function that generates the music. It's kind of a bite beat type of music, and maybe I'll play some of that later so you guys can hear it. It's definitely interesting. It's not the most beautiful music, I would say, but
it's even by chiptune standards, it's a little
yeah,
dissonant.
it's harsh. Let's say that. It's a little bit dissonant. So let's look at some of our favorite inspired tweets. So these are not tweets by me, but these are tweets by some other community members in Twitter that I saw and I just really loved, and inspired me to get into it. So like I think this tweet, more than possibly any other tweet, really shows you how beautiful and simple and like powerful this form of art can be. It takes you into this underwater cavern with such a small, simple bit of code that it just really blew me away. Like this one is just one of my favorites. Pavel does a lot of great stuff. Coming in a completely different direction, this one is a raycasting tweet. So this uses, now all the code to raycast is all in that same bit of code. I know it doesn't look like it, but oh man. Wait, what? Are these not working? It's not.
Oh, maybe it's not. Well, there has to be some power here that's working. Let's see if this works. Yeah. Pretty sure this.
That one is not working. Oh, maybe they're not. Oh wait, here's
I've had issues with the tables on
I'm
these
just gonna
things.
go plug it in the back.
That's what I would recommend. The wall will work.
Wall, yes. Can't go wrong with the wall. Word, we got it. Okay. So this one, I don't actually understand how that one works. It's pretty crazy. I did do some raycasting tweets, and I'll show you a little bit how the ones I made work. But this one is just so cool. It's just so simple and so like interesting. Like when I see these things, it really made me want to get into this because I had to know how is this even possible. This one is a little bit simpler. Maybe you could picture how this one might work because it's a more of illustrative kind of one, using just squares, rectangles rather, with the color red, and like this really simple effect, but so like ominous. So like there's like a story there. You know what I mean? It's almost like a whole like horror movie kind of there in that little bit of code. Here's another one I really love. There's so much variety to these, isn't there? Like this one, you have a top-down city, and if that wasn't enough, there's like these little cars that are like bumping into each other and like moving around and stuff, and they stopping at lights, it seems like. And it's just like mind-blowing how he managed to pull this one off.
So here's the thing that when I see these like impossibly impressive ones, and I know like anything gets well practiced, but like what even is like the train of thought? You go, okay, I want to make that, and what tools do you think of? Like you talk about the little bits bumping into each other. Like what does that suggest? You know, like how you do it in these contexts. You know, I'm just blown away. Like I wouldn't even know where to start to think this way.
You would not start with this, and I don't think Tomek sorted either. So you kind of build your way up. Like one way might be to start with just the buildings. Like how can we make, you're even not thinking as buildings at that point. You're just drawing rects in a grid.
Or there's obviously some kind of for loop of four loops of rectangles with shit. Because I mean, yeah, I agree.
There's only one for loop.
Oh, really? Right. Exactly. I was just saying, I could see, yes, I could think about, I could write the buildings even if like I wouldn't know how to get it that small initially. But
exactly, yeah. So you kind of like work your way through it, and you learn about new tricks, and you learn about different ways to kind of like make things work. Like I'm sure that the cars driving around, I think that was probably the biggest point of insight you got for this one, because I'm thinking it probably uses some kind of trig function to this code here might be where it does it, but I'm not sure how he's getting them to like stop at the lights and stuff. It's really weird.
well, yeah, the fact that it essentially has collision detection is the part where I'm how is he doing that?
Yeah, it doesn't though. I mean, that's the thing, like, each one of those cars is not separate from the other cars. Like, it's all one thing, and it's kind of like, how do we make it look like there are cars there,
Oh,
but there
I
are
see,
not cars?
it's kind of almost like it's phasing the way they move and the colors,
Yeah.
but you shouldn't, right, it's a continuous pattern.
Yeah, so if you imagine, it's probably more like you have an array of cars, that are all exactly the same distance apart from each other, and then there's like a lensing effect that takes place that smushes them. So it looks like they're moving and stopping, but they're actually not.
Right.
Well, I mean, they are, but it's all just, it's a big magic trick. It's smoke and mirrors, really.
And it's really, you have to reframe how you're thinking about it.
You do, you have to completely rethink things. And multiple times, like many times I've started to eat one way, thinking, I don't know if this will fit, and then I kind of like end up completely reworking it by the time I'm done, because it wouldn't have fit the original way I planned. Here's another one that works in a pretty interesting way. This is using the line 2 function to plot points. So it's finding these points to build a plane. It creates a function actually where you pass in one value and it does a line 2 using that value to create the plane, and then adds an animation to it. Just the simplicity of some of these, this is like the innovation of like thinking, like coming up with the ideas and making them fit, and it's crazy. I'm always looking for ideas. Here's another one with the 3D effect, just showing what kind of can be achieved when you start messing around with shadows and other stuff. You can get a whole lot of texture. It actually looks way better on like the Twitter website. One of the problems I have with sharing these is that it's hard to get it to fit in a GIF, and it's hard a lot of times that I put it in a video, it ends up compressing these so much that they don't look quite as good. This one is a new one that Tom Exor just released a couple months ago that we were all blown away by. Using his raycasting system, it creates these pillars. It's also got the blocks on the ground that are messed up, and it like there are two versions of this. This is the high definition version. There's also an animated version. Definitely one of the best tweets I've seen, for sure. So there's Top Link has also released a lot of abstract art on Twitter, and he kind of takes a different approach, where what he does is he kind of takes this kind of similar type of pattern he's developed and kind of plays around with it, tweaks it, and kind of keeps evolving it. And he's released like almost as many as I have on there, of just like these really interesting abstract works. So let's get into some of the ones I've done, because I can explain how they work a little bit. This is the first one I released. Just want to show you guys how I started. You know, it's just a simple place, hard, moving around in a very simple pattern. And I've come a long way. I've done over 1,300 tweets now. It's a lot. I actually did a lot more, but I deleted some of the worst ones. Kind of.
Sounds like you average about one a day.
I did, yeah, I probably do. Sometimes a couple a day. So there's all kinds of like, I would say, genres of tweets that we explore. Space is probably one of our favorites. There's so many different things you could do, from like stars to planets to playing with the emoji set and things like that. There's some really great space tweets. For example, this blackish holeish thing that I did is a spiral that spirals up in the bottom. This animation kind of shows you how it works. And it's a pretty simple bit of code, iterating with these stars circling around, using the sine functions, sine and cosine functions to make it wrap around a circle. And I could dig more into how some of these work. I actually wrote a whole blog post that breaks down this one and some of these other ones.
This one, I think, out of all of them, is the one I'm most of you being able to go, oh yeah, I see roughly how that's doing that. Roughly.
Yeah. Yeah, this one is not too bad. One of the trickier things that makes it look ugly here is like this eye question mark. I do this sometimes to do the first step in the iteration. I want something different to happen. For this one, it clears the background black first time through. So you're iterating from I equals 0 to 2e3. So when I is 0, clears it to black. Then all the other I's, it draws stars. So sometimes you can pack in multiple things into one like fill rect there. You can do fractals. I've done experimenting a lot with fractals. It's a really fun thing when you like get your first fractal to render from scratch. I think it's a very rewarding experience. And it's pretty easy to do like a Mandelbrot fractal, or also done Buddhist and anti-Buddhist and all kinds of stuff. So there's a lot you can do there. Here's a Mandelbrot for you. Just one of my smallest Mandelbrots. Just kind of drawing from right to left things. Some tweaks work in this way, where you're kind of like using the time variable to draw from left to right or from top to bottom.
Am I reading that right, that code is like mapping the basic trig functions to like combinations of them and aliasing them?
Yeah, you are. So,
Right?
so this is one of the tricks you can do in Twitter. So in JavaScript, if you have a variable that doesn't exist, and you try to like use that variable, it will throw an error, right? So what we can do is hijack some of the built-in variables so that we can, ultimately we're going to set the variables, we have to set them eventually, you know, but we can sometimes use the fact that they already exist from the beginning.
You don't have to waste space on constellet or var. You can remap the variable that's already there, basically.
Yes, more or less, yeah. So sometimes we are able to do that. It's something that comes into play, especially when you're trying to make something like really small. Like
Well, it looks
usually,
like you're also basically stuffing more complex function operations into the single letter, essentially, which, if I'm reading that correctly.
well, the letters there are just regular variables in this case. They're just working like so. Basically, what happens is this for loop. The first thing that gets here is you get s times t minus minus. That's the very first bit of code that gets hit. Now, those variables only exist because they exist as part of the Twitter shim.
Right.
What's going to happen here, though, is that's going to be false. And that's going to allow me to do some special initialization the first time through. You know? So it kind of allows you to save a few bytes. It's not a huge savings, but it's something that sometimes you need that savings. In this case, I didn't, because I actually have plenty of space here. It's way less than 140 characters. But sometimes you do need to do whatever you can do to fit it. If you guys know anything about cellular automata, like the game of life, for example, is probably one of the most well-known cellular automatas. Or if you're familiar with Stephen Wolfram, or any of his stuff, cellular automata is when you have kind of like a grid of values, and those values can change based on the neighboring values in that grid. And each frame you like update all those values based on a rule. And that rule can be like, you know, in the case of the water, it's just like taking those values and like spreading them out a little bit to make like waves. But sometimes the rules can be more complicated, like the fire one has a more of a turbulent system, or more mathematical, I guess, where you can create like either they call it a triangle, a Sierpinski triangle type of thing.
Yeah.
Or you can also create chaos as well with the same, create pure randomness with these cellular automata. So for a cellular automata breakdown, this is what's called a 1D cellular automata system. You just create, a 1D array of values that are just they're just either 0 or 1. And each frame we're going to draw one more row below it, and that row, those values in the next depend on the values above them, and with a special rule, and depending on what that rule is, you can get all different kinds of output. This rule happens to be a Sierpinski triangle, but There's actually rules that are Turing complete. I don't know if you guys have heard about that, but they proved that one decellular automata is Turing complete. So you can code any program in the universe in decellular automata. Another one of my favorites is cities. The kind of block-shaped structure of buildings and stuff kind of makes them somewhat easier to do than some other things. And we've been playing around with all different types of ways to, show these cities. Everything from a more like illustrative approach like this to more either a raycasting thing like that, where it's actually doing a full raycasting system, detecting shadows and stuff, or more of like a pseudo 3D thing like this one here, where it's actually more of a fake 3D to just make it feel like 3D, or isometric stuff. So this is another one that's more straightforward, I think, and there's a talk I did on YouTube that breaks this down as well. But basically, the way this one works is, the very first frame it does something special, where it draws the background. That's the blue and red, yellow thing on the background. That's what's happening on frame 0, which is this T question mark. That's something we do on Twitter sometimes when we want to get the very first frame, because T is going to be 0, T is time. So if T is 0, we do the sky part. That's just on the very first frame. On every frame after that, we draw a building, and we kind of randomize its position. And we just kind of shift these buildings down, and we randomize the light pattern, but it's essentially the same building, the same width, the same height and everything, but we're just shifting it down a little bit. And what happens is, like, after you get enough buildings overlapping, it forms a cityscape scene. We've also done raycasting, all kinds of different raycasting stuff. I've done a Wolfenstein type raycasting system. I've done more like a Minecraft type thing, or sometimes I'm able to fit additional effects, like the top left one has like this cool VHS effect that we managed to fit in. You can also do super high-res outputs. This one is like those other cities I had shown, but kind of just like tweaking the code so it's producing a super high-resolution output. So it's essentially the same as, that one at the top left, but a high-resolution version of that. And the way these raycasting ones work, it's not that complicated actually, and I did a breakdown of this on my website too. You're taking an array that starts where the camera is, has an X, Y, and Z position. And that X, Y, and Z position starts at the camera. And each frame, you're just moving that X, Y, and Z position out. Depending on which pixel you're drawing, that depends how much you move the X and Y position each frame. But ultimately, you're just adding a little bit to the X and Y position, and you're checking every frame. Is it hitting a building? Is it hitting a building? Eventually, that ray hits a building. When it hits a building, then you're going to just point that ray in the direction of the light, and you're going to do the same thing, step into the direction of light. Did it hit a building? Then you know you're in shadow. Did it not hit a building? You know you're not in shadow. So it's not that crazy complicated. When you actually work through the code, it does kind of make sense. Anyway, we've done a lot of stuff with trees. And I'm going to show you some more of those too. This is one of my favorite ones though, because it's so simple. And we iterated a lot of this one on Twitter too. Because I first posted this one in the top left. That's, trees, water, reflection, it has stars, it has, a cool little scene. And on Twitter, you're actually able to remix these tweets. So after a couple remixes, people really liked that one and did a couple remixes. And we were able to reduce it from originally 194 characters down to 119 bytes. And so the one on the top is what I started with. The one on the bottom, we had to get rid of some of the stuff, like the bluish color, and the stars kind of are not dots, but they're now lines, but very, very close to what we originally had. And that's kind of more of the code golf aspect of it. Because sometimes we'll take tweets and we'll kind of try to code golf them down and be like, hey, your tweet could be a little smaller if you know, do this optimization. Or sometimes we'll kind of just try to make them as small as we can. And so that was a really fun exercise we did. I'm not sure if anyone's ever heard of asemic writing. It's a very interesting art form. I had not heard it before. But essentially the concept is to create writing that looks like writing but does not actually mean anything. So it could be cursive, it could be print, it could be whatever. It could be like a script type of thing. So I experimented with that a lot on Twitter, and I had a lot of fun making like a notebook that has writing in it. And I did a lot of research on actually ancient Chinese calligraphy and stuff like that. And I did some tweets using that. Just really fun to just experiment with these like completely abstract shapes, but they like feel like they have meaning. You know, they're expressive. So to give you an example how something like that might work, for these type of writing, for what I kind of figured out is it's more or less a scribble, like a scribble. So you take like a circle or kind of scribble a little bit and you're moving left to right while you're scribbling. And then sometimes you kind of just stop scribbling and you just start scribbling again. And then sometimes you just change up how fast you're scribbling or whatever. And it's not that complicated, but I really enjoyed making these asemic writing tweets. They're very cathartic. We've even done people, tiny people in tweets. People, I mean, a little fighting game, people running, people falling. So when you're making something like this, you really have to think about how to construct it. And that's the whole thing about tweets, because like I said, it's really magic. It's really, nothing works the way you would normally think about how would you program a person, you know? You're thinking arms, legs, head, things like that. You really need to rethink all this stuff when you're dealing with Twitter and how to do things simply. So for example, this person is drawn by drawing 4 lines. Every line starts with the head. You go head, you go neck, you go elbow, you go hand. You know, boop, 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 boop. That's one arm right there. Then for the other arm, it's just the same arm, but it's offset, right? It's offset by a half turn, whatever. And then the legs are the exact same thing, but instead of going this way, they're just, you know, flipped around backwards, right? And instead of the bending at the elbow, they're bending at the butt. So normally you have your hands are bending up the elbow, the legs are bending down here. And so you're just drawing 4 lines, and each one of those 4 lines is 1, 2, 4 points, I think. So it's just a totally different way of thinking about how to create form and characters.
It seems there's a lot of like identifying commonalities and seemingly different things and using rotation or translation to make those similar different things.
Absolutely, yeah. That's one of the key aspects of Twitter is like taking some bit of code and thinking how can I get the most out of it? You know, how can we either make that same bit of code be 2 arms and 2 legs, or how can we make that same bit of code be a building and a tree at the same time, or whatever. It's always like packing multiple functionality into, you know, on top of things, making one thing do more than one thing. I also think of it as like a holistic approach to programming, because so much of programming, we think of things separately. Like, here's this function, we know it works, separate function there, there's this function, we call in this API, whatever. But with Twitter, you really need to think of everything all at once in one holistic kind of bit of code. And really for all size coding things. You need to think of everything together, because you do not have any space to waste.
If your architecture is not rock solid, it's just not going to work. You have no
Work.
space.
Exactly. Exactly. Landscapes, also. I love nature, you know, and expressing nature in a tweet is really fun because it's basically the opposite of nature. Like, it's just a tiny bit of JavaScript literally the opposite of nature. So I find it enjoyable to try to shove nature into there too. Landscapes, yes, they're one of the most popular ones we've done. Like sometimes it's not just like the shape of the landscape, but like the style of the drawing style of it. Like here's one where I kind of wanted to give it more of a crayon look. And it's just using fill recs. That's all. All those recs are just vertical recs, you know, and they just I'm just playing with things like the opacity and the length and the width and stuff to make it look like a kid had scribbled in this landscape. I'm just going to shotgun through a few more of the tweets here. Optical illusions, I really love, and I've explored all kinds of. A lot of times I'll see an optical illusion and I'll think, I bet that could be a tweet, and almost always can be. So pretty much any time I see one, I kind of want to try to see if that's possible. And Twitter is a really great way to mess with this stuff because you have the code, and once you have it, you can keep iterating, you can play with it, you can share it, you can I see people share this literally this thing or even this one I created on Twitter all the time and get hundreds of thousands of views. I don't know why. People love optical illusions. People love optical illusions. I don't know why. Chaos systems. If you know a Lorentz attractor, I've got one of those. I've got systems that draw and interact themselves while they're drawing, almost like a ice type of thing. All different types of exploration of chaos, I guess. But the thing about chaos that makes it most interesting is just riding that edge of chaos and order. Because if it's just pure randomness, that's not interesting. We can also do physical simulations in this small space. We can do, collision. We can do particle systems. We can do water simulations, bouncing. What's it called? I forgot that one in the middle. I don't know what it's called. There's a lot we could do. We're still experimenting with more physics stuff. Trees are another one. Like I said, nature is one of my favorite things, and trees are growing along with that. We played around with them a lot. Everything from more like a palm tree, which is basically a firework. Basically the exact same code as a firework, but one of the things that come in the firework is longer. That's the chunk. Then you've got birch trees, bamboo. We've even done a 3D stuff, 3D trees. Geometric design is one of my favorite things for tweets. I don't know if you guys are into recreational mathematics, like Numberphile, or if you've heard Martin Gardner's work. Every time I hear any new math thing like that, I always want to see it. I want to play with it in a tweet. Because those recreational math concepts, they often are, perfectly fit into it, and they're easy to explore and fun to play with. And a lot of these ones came from those same ideas. Here's a spiral graph.
Do you ever a lot of those math videos actually often to explain these hard math concepts already have animations essentially showing it? Do you ever then try to go, well, can that be expressed in a tweet that's small? Do you look at say a 3 blue 1 brown video and try to do his thing in a tweet or something?
Absolutely, yeah, I do that all the time. Yeah, we have a lot. I think that is one of the most direct inspirations of tweets because it's recreational math, and this is recreational programming. I don't think it's really that well used of a term or known of a term. A lot of people say recreational math, but even that is not that well known outside of people who are, it's still kind of niche, even though it's not. I mean, people know who MC Escher is, right? I think, but people still don't know, and recreational programming is even smaller. But recreational programming is basically recreational math. So yeah, okay.
Here's a tangential question though that I find myself curious. You talk about continuing to find what you can do. Have you in the community concluded that there are certain things that simply cannot be done in a tweet? The minimum space you need to do it is just bigger than that, and there is no way to do it.
could always make a program 1 byte smaller. So we don't know.
Well, that actually gets interesting, in an interesting debate I was having with a friend one time about like, well, obviously with sufficient aliasing, you could express a program in 1 character. So we start debating computational complexity theory and like, well, what's the minimum entropy you need to say?
I know, I mean, you would think these programs do have a minimum entropy, and they certainly do. But, I mean, from the mathematical side of things, obviously it seems like there is a minimum size to express these things. But on the flip side, I can only speak from personal experience that every single time I've ever made any program, I've always found a way to make it smaller afterwards, always. So I can only imagine that, and we're continually finding even new techniques. Not only that, but they're adding new functions to JavaScript. We don't know what JavaScript is going to contain. They've just added a new function recently, a rounded rec, to the, I guess it's not that complicated a thing, it's just a rectangle that's round, has round corners. But
that
do not
alone
exist
can
a year
let
ago.
you do a lot of stuff a lot more efficiently.
It could. But there are other things that could be way huger than that. You know, that if they ever happen, or like operator overloading, or things like that. You know,
Or like Canvas supporting like voxels, so you could do crazier high polygon count things. Because I was thinking one of the things most of these don't do is like, well, they're still kind of pixelated. You know, none of these are fully
Absolutely.
realistic. You know.
Well, that's another thing that is, we're only limited by time there, because as computers get faster, the only reason those are low resolution is to make them run at reasonable speed.
Oh, and you could literally just keep running render passes on the event loop, and there's in theory no limit to how detailed you can get.
Yeah, you could just do like, I've done high resolution ones, they just take too long to draw.
Right.
So as the computer gets faster, we'll eventually be able to do higher resolution, you know, programs. It's kind of cool that we're still, and this has been around for a long time too, because it goes way before JavaScript. This goes way back to the early days of computers, and still today people are releasing new programs, not just JavaScript, but like I said, MS-DOS and other programs exploring. But there's a lot of overlap because they're using similar techniques to what we use in JavaScript, even though the functions themselves are different.
The big sort of, what I heard you saying, kind of big difference breakthrough here, is to have this power in an interpreted language so you get that real-time instantaneous feedback, no compilation.
Yeah, that's huge. That's huge, and that's what I love. Tunnels or something, and a lot of these tunnels all use the same kind of setup. Playing around with words and just typography, and you know, kind of a fun topic to do. I've explored with so many different things. It's hard for me to even put this talk together because I've done over 1,000 of these, and they're very different, all of them. Like I've done tiny little pixel characters, I made a carrot, I made flowers, I made a tower, I made basically anything I can think of. I still keep thinking of new ideas, but yeah, I went hard on it for a little bit, to say. So, let's come to the end of my talk. So, why write tiny code? Well, hopefully you understand why I do it. I think it's fun and relaxing. I really enjoy it. Sometimes I'll be like, watching a TV show or whatever, and I have, the code up and, chip away at it, whatever. It's not a project where you need to, really, dive into some huge project. It's something you can kind of just, bring up and kind of hack away at here and there. And I have, a couple tweets I'm working on at any given time. It's a really great way to practice your coding skills. I basically learned JavaScript from doing this. Thankfully, I've come a lot further, but I learned a lot of the basics of JavaScript. And there are also competitions that you can get into, the demo scene, and everything. And it's just a really fun community, I think. It's a really great group of people, and a small community too.
I find myself wondering, as far as, you'll just become a better coder doing this, are there things for your drawing in your day job of making games where you wouldn't have known how to tackle a challenge at work, but something you learned from Twitter gave you the insight to know how to do it?
Well, I've completely changed how I code since I used to program in C++. And I used to work on these massive projects that would take like, just like one file. You would just like hold page down and you'd just be like sitting there. And you'd be like, how big is C file even is one of the files in the project?
You go back to the days where you'd actually find a 20,000 line file and would not have it rejected from code review.
Yeah, so like it's completely changed how I approach programming, how I simplify things, and a lot of times I use not Twitter, but the Cap.js, which is a website I use that's basically the same as Twitter, to play with ideas and from larger projects. So like, let's say I'm working on a larger project and I want to, I don't know, do something with a list, or I want to, do some kind of operations. I want to do something, I want to mess around. I will bring it up in a tweet and play around with it in there in real time, get it working real nice, then bring it back to my, other program. Because iterating like that is just way faster and easier.
Well, yeah, I mean, I think almost anybody who codes in web languages, bare minimum, will use sometimes like a JavaScript playpen where it's like, I don't want to have to deal with all the build and all the infrastructure, deploy this, I just want to see, am I on the right track? Is this little bit of code going to do what I think it's going to do?
Absolutely, yeah, the console's a great way to do that. The difference here, though, is that it just gives you the canvas straight up, and it gives you a loop that you can kind of play with to really help visualize things. Because that's one of the things I found with programming is like, for me at least, visualizing things is really, really important for me to understand. It's not a console or even a debugger is not always enough.
I think that's an excellent point, because I think that's, I did a bunch of really crazy math classes in college, and yet with this revolution of these recreational math YouTubers with visualizations, I've literally had, I don't know how many light bulb moments of like, oh, I actually finally get that. Like, I thought I did in school, but I'm like, no, now that I have the visual, I actually finally get it.
Yeah, they're great. I mean, if you guys haven't seen 3 Blue 1 Brown or number files, another one of my favorite ones.
Mythologer is another good one.
What's it called?
Mythologer, yeah.
Mythologer, yeah, that's a great one. There's a lot of those are for math. There's similar stuff for physics because I get inspired by that stuff too. Definitely check that out. There's not much for recreational programming along those same lines. I wish there was. Maybe I'll start one someday.
I did find a guy who explained very nonsensical code in one of the Doom games and explained how it just seemed like random stuff, but it was a very smart way to hack some 3D rendering thing, and that was fun to have him step through it. But there's not as many as you hope.
There are a few of those, and I will soak up any of that content again. But today, so if you guys like this, what I want to invite you to do is post some of your own tiny code. You don't have to use Twitter. You can use whatever interface, whatever code language, programming language you like. But the idea is to just post a tweet, or you don't have to use Twitter. You can use Blue Sky, whatever you want to do. But you post the code straight in there, and if you have an image to go with it, you post the image. Lots of people have done it. I don't know if you guys have seen any tweets people post and you like wonder what they're doing. It might be something like that. And I want to thank everyone for watching. Thank you for coming out and braving the storm. Thank you to EFF and Capital Factory. I have a few bonus slides after this, and I also have I could show you guys how some of the live coding thing works too. If you like to see. Yeah, okay.
Yeah, we have the room for another 30 minutes, so
Great.
if you'd like to do a little bit of demoing, sure, feel free.
Oh, cool. I'll do a quick demo. I also want to mention I have artwork for sale. These two guys are $200 each. All my artwork is a one-of-one unique print. I also have art hanging in City Hall right now, which is that picture right there.
Congratulations.
And yeah, thanks. As part of the People's Gallery, that's on sale for $500. And this stuff is all free if you'd like to grab one of these. The business cards are all one-of-ones, like I said. Everything I do is, because I do generative art, right? So it's all, I don't ever have to print the same thing twice. I could just regenerate a new piece of artwork. So I kind of have a company, I guess I do. I just don't, it's just
you may
not
promote yourself.
I'm working on it, we're trying to figure things out, but I do all kinds of things. I do video games, I do promotional stuff, I made a video game for the band called Squid. They're a UK-based band, and they wanted to promote one of their songs, so I made a playable video game you can play on the web or on your phone that's like synced up to their music and stuff. I do educational content, I do artwork. I also made LittleJS engine, which is a tiny JavaScript game engine. And I also want to mention next week, if you guys, if anyone's down, come out to the Games Y'all. So this is the Austin video game indie dev meetup. I'm going to be demoing my game Driven Wild. This is a 13 kilobyte game, which is pretty small, not nearly as small as a Dweeb. But I'll be showing that, and we're going to have like a tournament and stuff. So, without further ado, let's see. I have a small demo plan. I'll see if I can conjure it up here. All right. So let's show you Twitter.net first.
Oh, I just had a light bulb moment of realizing, oh, Games Y'all is what used to be Wagos Rancheros. I'm like, okay, now I know what you're talking about.
So here's Twitter.net. It's a very simple website that has just the key functionality of being able to comment, post tweets, remix, stuff like that. And so you can scroll down, you can see your tweets. You can also see the newest tweets, the top tweets of the month, whatever. So I encourage you to create a new user and start messing around there. Feel free, if you don't want to start from scratch, totally fine, totally normal to just remix another tweet, make a few changes to it. So I made a couple other websites. I don't know if they're going to work, how well they'll work on this laptop. One website I made is called Tweet View. This is just an easier way to browse tweets. So you can just, because this is using an API. The API is accessible, so I'm just hitting up this Twitter API and grabbing the tweets if you want. I also did this tool called the Tweetabase. Every single tweet ever made is in this JavaScript file. It's not a very big file, really, but I like that all my tweets are not locked behind some platform where I don't have access to them. I have everything here. Everyone can download all their tweets if they want, and you could browse through them really easily. But what I'm going to show you is the program I usually use to edit tweets is not Twitter itself. Like if you load a Twitter, you could start a new tweet right away, and you could start changing stuff in here. Like I could change how many of those there are, or whatever. But I don't use the Twitter. I mostly use this tool called CapJS, which was very similar to Twitter that I wrote. Am I in dark mode? There we go. So I want to give you a very simple demo of how to create a randomized star field, just to start out with. We'll create a star field. So how could we do that? Well, let's kind of delete what we have. So hopefully we see what we have already. It's just, yeah, let's delete that too. We're just going to start with a simple for loop. ID3 means 1,000, right? It's 1 times 10 to the 3. So we're just going to do fill rec I99. So what do you guys think that's going to do? That's just going to draw a line, right? Because X and Y are the same. So what if we don't want to do a line? What if we want to mix that up? What if we want to randomize this? Well, how did I say we could do that kind of thing?
Well, trig functions is an easy way to sort of
Yeah, so that's absolutely true. So you can do sine of I, so that's going to give you between 0 and 1. So now it's all in the top row, which needs to get bigger. Here. So now we've got our randomization. We're going to make I go the full way through. 1920, that's the width. The height is 1080. So we've got a little bit of a problem here. It's not that random. So let's try to make it more random. So let's do I times I. There we go. Now that's random, huh? And then we can do plus T. Whoop. No. You know what? We need to clear out this too. So let's add clear.
That's actually really neat what you just went to do.
So we got our clear here. So I'm just going to swap the x and the y coordinate because I want to kind of go from left to right instead of top to bottom. So we got left to right.
It's like it's a spinning cylinder.
It does. So you'll notice that, I mean, that's one of the things that I've learned a lot about trig functions. I get a much more intuitive sense, I would say, of how trig functions work. Because they, does it look more like a spinning cylinder now?
Yes, so what is the intuition about them that this has taught you that you just like know how a cylinder is encoded by them and stuff like that?
I guess I just kind of have a lot more of a feeling of how sine and cosine and tangent work. I already knew how they work, but now there's a much more, like, imagine just sitting here I've done this thousands of times.
Right, but you have a more intuitive sense of, we forget that they're ultimately a ratio that encodes a lot of geometric relationships, and you just have more of an intuitive sense of, yes, this is this shape because of the underlying relationship.
It's a three-dimensional shape.
So kind of lost in how this comes to. You still draw like a diagonal line, and I guess I could.
It did, yeah. So here's the line again. So if you do, so that's the line, right? So we're going to mess with the x coordinate here.
Okay. So that fills a rectangle. It's making a rectangle, right? It's filling it, or-
Well, yeah, each rectangle, well, there are
Oh, sorry,
1,000 recs.
points.
Each rec is only 9 by
And then the
9.
rectangle is from like the I coordinate.
So each rectangle is just this tiny little, I'll make it.
Yeah, they're little, so basically I think
They're
fill
so tiny.
rect, the way it works is
They're
the
almost
first
dots.
two are the starting corner, and then those are offsets, the third and fourth.
So it'd be like 0, 0, 9, 1, 1, and 9.
Yeah.
Okay, so it just fills up that whole thing.
Yeah, you don't need to use rectangles either. Use text.
The point is essentially, maybe this begs the question, why not just use pixels? Why use these little small thingies that are essentially functioning as pixels?
Well, well, there's no direct way to output a pixel, but if you just do a 1 by 1, it's going to be too small to see. That's why
Okay,
you
so
find-
1 by 1's too small to see, and it only gives you filled rect. There's no direct pixel.
There is a direct pixel, but it would take way more space to do. Because what you can do is access the canvas data directly.
Right.
You know, get a full dump of
I
literally
could dump
that
it and literally
bitmap.
go in the array, and
You
there's the
can,
pixel.
yeah, but it's obviously you don't want to do that. You want to be able to interact with it a lot easier.
Well, and the whole reason the canvas is powerful is it supports scalable vector graphics and not just bitmaps,
Yes.
basically.
But though we do deal with them on a pixel level for some tweets. I mean, it depends on the tweet. I mean, for some tweets we do that.
Some tweets you need pixel level
Yeah.
manipulation.
But for this, I think I don't want it to be a cylinder. I think I just want to move it from left to right. I just want to move it from left to right. So we're going to do an or, 1920, that's the width. So we got we got T is the time. So we want to make it move a little faster here. We got to move it faster. But we want to make it like, move at a different speed depending on which star. So we want some variation to the speed, right? So we can do I mod 3 to get a little bit of variation. Now it's doing I can be 0, I can be 1, I can be 2, right? I mod 3 could be 0, 1, or 2. So now it's giving a little bit of variation to the speed here, right? So this I times I thing, I think we don't need. If we go back to I, you'll see we're going to have trouble again.
But it looks like mod is a very common way to essentially get loops within the loops of the drawing and offsets.
Yeah, because we want to keep this from going off screen. If we don't have the mod, what's going to happen is, if you don't have the mod, it's just going to go off screen. In fact, it's so far, the bottom ones are so far off screen you can't even see them. So now we've got a little bit of a star effect. So we want to jazz this up a little bit. So what I'm going to do is change it to a black background. So I could do that by I'm just doing a full rect just doing a big fill rect, 2v3, it's going to do a 2000 by 2000 rect. And I want to change this fill rect to be a clear rect. So I'm just going to clear out a spot instead of, you know, now you might see this is not quite that random. There's a little bit of I don't know if you can tell, but there's a little bit of a, it's easier to see when it's moving actually. Do you see that?
Yeah, there's those weird bands.
So we can get rid of that a little bit easier by taking this to a higher power. But if you take it to a like fractional power, you pretty much get rid of it entirely. So that's how we can get a little bit of a star field thing. So let's take this a little bit further and see if we can turn this into some fire really quick. So how do we turn stars into fire? Let's see if we can do it. So I want to make them go up instead of sideways, so we'll do that first. We'll start at the bottom. And we're gonna shift this over a little bit, just so it's more in the center. Kind of like a fire type thing. We'll make this a little bit smaller. So this is kind of where our fire's gonna live. Fire's gonna live right there. Now you want to, you need like a lifetime thing. You know, sometimes I'll use brackets while I'm messing around to make it easier. So you need like a lifetime, like how long is the particle between the bottom and the top, you know, but we already have that right here, don't we? So this is that. So let's call it Z. So that's just representing, you know, how far is it from the bottom to the top of the screen. So we take Z, and that's being modded by 820, so we can just do Z over 820. That's going to give you a percentage that goes between 0 and 1, right, between the top and the bottom. So let's make them change in size from the bottom to the top. So how much you can use a R, that's going to be your radius, we'll call it. So do your radius times P. Now look at that. We've got them small going to big. So how can we change that? Well, let's do 1 minus P. Now we got big going to small. Getting a little bit closer to fire, am I right? Okay, so now we're going to use the fill style. It's pretty cool seeing things change like right in front of you, like this.
No, you're right. I see why compared to the old compiled days, this has a much more immediate reward.
So we are going to do, oh yeah, I also need to do, I need to make the fill style. So I'm going to set the fill style for each particle, but I need to set it for the background too. So the background's going to be black. The particles are going to use, they're using clear rec right now, I'm going to use fill rec in order to get that color. I'm going to use a HSL color. So I'm going to use this little guy here. Then I'm going to use just your standard HSL, pay no mind to that. If you're familiar with how HSL colors work, that's all I'm going to do here. So now we've got a little bit of color. Fire actually goes from yellow to red, not red to yellow, so we're going to use that. And it's getting a little bit closer.
The thing I'm really intrigued by is how it almost has an effect of that, like it's falling back into the screen, even though I know that's just an optical illusion.
Now we can do circles instead of squares. But I do need to do call begin path, I need to call fill. These are kind of things you get used to with the Canvas API, but you can make your own function if you want to draw a circle. But ultimately, you just call begin path, arc, and fill. And 0 and 9 is the start and the end angle, but it doesn't really matter as long as it starts at 0 and goes past 2 pi. So we've got that. Now there is a thing called the global composite operation. It takes a lot of space.
So what does it do? It better be worth it if it takes so much.
It does. I don't use it very much in deletes. What it does is I don't know if it's going to work. It allows you to control the blend mode. So you can do additive blending. Don't usually need to do this, but I'm not sure why. Go back to default blending. And basically, let's use additive blending to get more of a kind of Fire look to things, I think, because Fire has kind of an additive feel to it. Now I'm just going to continue tweaking this. So let's say we might want this to be a little bit lighter. And this is kind of how we might work on tweets to iterate. Oh, no, I feel like more like that. Oh, that's not right. And a lot of times I'm just wondering, like, why does the code not do what I think it's supposed to do? Let's add a little bit of motion to the left and right motion, just like a wavy motion. Like, check what this does to it. We do a sine t. Now, see how it's moving left and right? Whoop. Want to make it faster? Do it faster? Too fast? Okay, that's about right. We want to move less amount though. We wanted to use that randomness thing we talked about before. So now you see how they have a little bit of randomness? See that makes it feel a little bit more like Fire? And
so is it a general principle that the higher a power you raise it to, the more random it will feel?
No, but it can be no. Somewhat. Sometimes.
Yes and no.
Yes and no. Well, there are things that can happen. So squaring things definitely usually causes some noticeable non-randomness.
Is it due to the symmetry of a squaring operation? There's a pattern that will get introduced.
I think it's more just because of, like you said, in the way, the more you power it, the more kind of randomness it gets. But there's another thing that happens, which is you get, if you use the same power different times in the code for the same thing, these random numbers get kind of tied together in a weird way.
Some of it has to do with just like, how big a sort of phase space you made before it might loop and start repeating itself. And the more space it has to play with, the more random it can feel before it will loop in some way.
Yeah, something like that. Something like that.
I don't know.
Something like that. So I think that gives you kind of an idea for how to kind of get started, hopefully. So what you can do is you can grab any one of these tweets if you'd like. Like say like, let's get one that's kind of interesting. Okay, here's one that's cool. So you can take this tweet, just copy and paste it right into my tool here. This tool has some extra features to like capture GIF, to get screenshots and save things out easier. That's why I use it mostly. But it's essentially the same thing as Twitter. And once you copy the code into here, you can start just kind of, messing around with it. That didn't do anything. This is not my code. I'm just kind of poking around and seeing what happens there. You can kind of eventually get it to do some cool stuff, maybe, or not, It's up to you. Or sometimes, like, so the first thing I want to show you guys, like, when you get this code in here, what you might want to do is space it out a little bit. Like, you don't have to work with it in a cramped environment. That's usually the last thing I'll do, is kind of start squeezing things together. So you might want to, when you first see a bit of code like this, you're like, how does this work? Okay, that's actually a separate line. This here.
You don't have to go full minification while
Yeah.
you're learning what things do. Maybe even replace a variable name with something more descriptive if it helps you track what it's doing before you minify it.
Yeah, absolutely. Yeah, go and comment it out if you need to. If you want to bring it into another program or whatever, whatever you come up
Gets
with.
into a question I sort of had where like, are there, I see a lot of similarities of what these programs do with what just, a JavaScript minifier does, but just like how you pointed out, well, code golfing's subtly different than what you do, say is like a key distinction of like, well, a metaphor does this and this isn't about that, or vice versa.
Yeah. Well, I guess one of the biggest things is making concessions and changing, being willing to slightly change things, because with code golf, that you can't make, you have to have that exact same output, or it's not correct.
Right.
But here, it's like you might try to make something smaller, and you think, wow, that looks kind of better, or that doesn't look quite as good, but I need to go with that because it's the only thing that fits, or whatever. So that's, with minification, the idea is like code golf, like you don't want to change the output, you want it to keep working.
Right, they have to be one-to-one things of like, yes, I can replace a 5-letter variable name with one, and it's absolutely syntactically equivalent, or I should say semantically equivalent, but here it's like, well, I might literally have, you might have to change it a bit to get it to fit.
And there are also other things you can do that don't change things technically, but the minifiers won't do because it's kind of not kosher. You
But
know?
I think a good example would be like, a minifier is not gonna turn 100 into 99 because that value needs to be 100.
Well, that's the
Here, you might
concession.
change that because you saved the character and it didn't really change that.
That's a concession thing, but what I mean is there are things you can do that don't change the output that the minifier will do. Because it's like I said, it's not a kosher thing. Like one thing you might do is, like if you have a function that takes one parameter, you might just use not extra parameters, but you just want to put something that gets executed in that same code block. So you make it look like like I have sign, only takes one parameter, but I might do comma dot dot dot, because I want to do a little extra code there in that same code block. But a minifier is going to not put something in a function that doesn't belong there. More than anything though, what it comes down to is the holistic design. And thinking about things in the first place, because you can't just like write some code and be like, here, minifier, make it fit in a tweet. It's not gonna know how to do that. Like you need to, from the very beginning, or not from the beginning, but along the way, like come up with a holistic approach to making your program work.
Yeah, the minifier is just a blunt force algorithm that has its rules, and they may not work for what you're trying to do.
And minifiers are great too, by the way, because I do some larger size coding stuff where the limit is more like 1 kilobyte, or some things where it's 13 kilobytes. With those, I don't want to do hand minification on every single thing, because not only is it too cumbersome, but it makes the code very brittle, and it's not something that is good long term, you know. So I will write my code in such a way that the minifier is able to work very well, and I'll just run the minifier on my code. But my code is already done in a holistic, smart way, so that the minifier will work well and the code will fit. If that makes sense.
Yeah, it is. I hate to wrap it up, but we have about 5 minutes for the crowd wants out of the room. Do we have any final questions for Frank before we call it an evening?
Questions.
Well, I
If you have any
suppose-
questions, feel free to reach out. You know, I love helping people get involved in this. We also have a Discord for Twitter. You're welcome to join. Follow me on Twitter or Blue Sky,
Well,
wherever
I
it is.
certainly want to give you a big round of applause, because frankly, your work is very impressive stuff.
Thank you so much. I love doing this stuff. I mean, I've been programming for like 20 plus years, but this stuff that I just started doing in 5 years is probably my favorite thing.
Well, yeah, and I mean, even as somebody who keeps trying to slowly learn a second language, I see so many parallels to what you're doing, and like, oh, well, it's this neat way of combining the base building blocks, and then it builds this idiom that actually communicates this other thing. It's very similar, and I like the elegance of it.
I like it encapsulates ideas and concepts, and I can go back. A lot of times I'll go back to Twitter and search for something, just because I'm like wondering, like, I remember there's this thing. It might not even be graphically related. It might just be like, sometimes we'll post HTML, something with HTML or whatever weird. It's like, I want to know. It's a great way to store the.
And just, it graphically teaches you, like, what is the core of something, you know? Because, like, you know, that you actually maybe ponder, like, what actually is it that makes me think something is fired visually? What are the actual core
It
elements?
absolutely does. It absolutely does. I don't think I quite got there with that Fire one, but Fire is one of the many things that is fun, because everyone knows what Fire looks like, and it's not that complicated of a thing. But And there are many ways to do fire. Like, you can use cellular automata, or you can use like we more did, where it was using circles and stuff.
Awesome.
So please feel free to take one of my business cards or one of my.
And then next quick question is, does anybody need parking validation? Because I have those who do.
I need that.
Like one. Anybody else needs one? I got them. And I will also just flag, as always, after talks, we invite anybody to get a drink at the bar who's able to stick around. Otherwise, we will see you probably in April, because we're skipping March here, as I said, although we may do some events, watch our meetup and other things to find out if we do something in March or not. But yeah, welcome to join us. Otherwise, have a good evening.
Thanks so much for coming.
Well, and also, I also figure also usually it's such a hassle to get here, you're like, well, I'm already here.
Just the wrong thing. Yeah, no.
Oh my God, that's not
work.
You know what, we do have protection for that. We do, it's called loop protection. So what the way it works is it takes the code and looks for while loops and forms, and it puts in a little extra code, so there's loops to make sure that they don't look too much. It doesn't always work, and you're right, it is a little bit frustrating. I was joking myself, I was like, man, it's like the entire problem.
No,
But we have it found most of the stuff.
I'm not, yeah, you see what I'm like?
Yeah.
I see what you mentioned that.
Yeah.
Oh, no, that was me.
Oh, okay.
Yes.
Alright, so do we have anybody who wants to go over to the?
I mean, I'll be going. I'll be there. I'm just seeing.
That's my new run of cards. It's based on a pretty complex JavaScript program that generates space-themed comic books. It does everything from the layout of the page to just the scenes and the clouds. There's a whole lot of different parameters and colors and stuff. So I used it for my business card, but it was originally a completely different project.
Man,
so darn cool.
That is pretty epic stuff, I must say.
There you go.
Yeah. You gonna go to the drinks for a drink break? You gotta get going.
Yeah, I'll stop by, sure.
Oh, thank you. See, it doesn't matter how cool you get, you're always a forgetful nerd. Like, yep, it's still open.
You know, we're like super NSA hackers, they're also little goops of security holes.
Well, I'm always tickled by the NSA just being like, why can't we hire perfect nerds? We can't even find one that doesn't smoke weed. Story, by the way.
So, have you ever cleared your Microsoft Windows?
It's like all the things that make you good at the job are things they don't want you to have done. It's a problem.
I know, it's like, this stuff, I've actually seen this cellular.
It's like, we want you to be a big believer in never breaking the law, but we need you to have skills that to get good at them, it helps to break the law.
Like practicals, I mean,
Are you?
Well, I mean, fractals are something that you can do with it. And they are, and everything works the same way. And cellular automata is, believe it or not, very
they're getting a
different
little
from
melted out.
fractals.
Leave it exactly like that.
Great size they would think of the crayons are like
simple
this.
If they're gonna.
That's true.
Not for
Still need
like,
it, so I
because
think
that's
that's
what I
true.
think about what is that cellular